As I said in the previous class, in this class we will discuss the inverse relationship between rate of interest and bond price. The inverse relationship between rate of interest and bond price. In the Keynesian model of demand for money, there are only two financial assets, money and bond. You can keep your wealth either in the form of money or in the form of bonds. In the classical theory, remember this, money is used only for transactions. No one will keep any money in excess of what is required for transactions. Now, bond is an imperfectly liquid asset. Since to convert it into cash, you have to sell it in a market at the risk of making a capital loss if selling price is less than the price for which it is purchased. So bond is an imperfectly liquid asset. Because if you want to convert a bond into cash, you have to sell the bond in the market at a price which may be greater than or less than the price for which it is purchased. So there is a possibility of a capital gain or a capital loss. So there is a risk involved in the context of a bond. Now what is a bond? A bond is a fixed income yielding asset. It's a fixed income yielding asset. It has a face value. It has a coupon payment also. It has a face value and also a coupon payment. Face value is the price at which the bond is sold in the market. So for example, face value is ₹1,000. Coupon payment is the rate of return the holder of the bond will receive on an yearly basis, say 100 per year. And what is the rate of interest then? It is 100 by 1000 is equal to 0.1 or 10%. If bond is a fixed income yielding asset with a given maturity period, say 5 years, 10 years, etc. It has a face value, also it has a coupon payment. If you purchase a bond paying ₹1,000, having a maturity period of 5 years, the issuer of the bond will give you, say, ₹100 coupon payment every year. And after 5 years, this 1000 will be returned to you. It is something like keeping what is known as fixed deposit in a commercial bank. The difference will be considered later. Now this is the character of a bond. It's a fixed income yielding asset with a face value, a given maturity period and a given coupon payment. And this coupon payment is what is known as the market rate of interest. Remember this, in the market there is only one income yielding asset. So return on this asset is the market rate of interest. Now let me define what is the price of bond. Now the price of bond in the market is the present value of the income stream to which the bond is a claim. Bond price is the present value of the income stream in which bond is a claim. We have discussed present value etc. in a previous class in the context of investment. Anyway, we will discuss it once more for the time being. Bond price is written as the present value of income stream to which the bond is a claim. I write it as AN by 1 plus I plus AN by 1 plus I square plus etc. AN by 1 plus I raised to n plus R. And AN is the annual income received from the bond. So for example, rupees 10, rupees 100 that I have suggested earlier. And R is the principal amount received after 5 years, say 1000. And I is, as it is known to you, the discount rate, the rate of interest. That is the rate of discount at which this annual income stream is discounted to obtain the present value. So AN by 1 plus I, AN by 1 plus I square etc. AN by 1 plus I raised to n plus R by 1 plus I raised to n. This will be the bond price. Now, if the bond is a perpetuity, if the bond is a perpetuity, as an example, UK government's consolidated fund, UK government's consolidated fund known as consols. Perpetuity means a bond with no maturity or a bond with a long maturity, 30 years, 40 years, etc. A classic example is the bond issued by UK government, that is consolidated fund known as consols, having a maturity of 30 years. Then bond price is equal to, if it is a perpetuity with no maturity or a long-term maturity, then this R will not have any value. In that case, we write it as AN by 1 plus I into sigma T is equal to 0 to infinity 1 by 1 plus I raised to T. If it is a perpetuity, we can write the bond price as AN into 1 plus I into sigma T is equal to 0 to infinity 1 by 1 plus I raised to T. Or this can be written as, this is nothing but, so bond price is equal to, the first term is AN by 1 plus I plus AN by 1 plus I square plus etc. up to infinity. So AN by 1 plus I cube etc. like that. AN by 1 plus I plus AN by 1 plus I square plus AN by 1 plus I cube plus etc. up to infinity. So that it can be written as an by 1 plus I into 1 plus 1 by 1 plus I plus 1 by 1 plus I square plus etc. The bond price can be written like this. Now as you can see, this is the equation of a geometric progression with the first term an by 1 plus I, common ratio 1 by 1 plus I. Since 1 by 1 plus I is a fraction, this can be written as equal to an by 1 plus I into 1 by 1 minus 1 by 1 plus I. an by 1 plus I into 1 by 1 minus 1 plus I. And taking LCM here, 1 plus I, 1 plus I minus 1. That will give you I by 1 plus I. So 1 by I by 1 plus I, or 1 plus I by 1 by I. 1 by I. That will give you an into 1 plus an by 1 plus I into 1 plus I by, so that is an by 1 plus I into 1 plus I by I will give you an by I. So if the bond is a perpetuity, bond price can be written as equal to an by I. Bond price is equal to an by I. That is, bond price is simplified to. Now if an is 50, that is yearly return is 50 and I is 0.1, 10%, bond price becomes 500. Bond price becomes 500. Or if the bond has a face value of 500, which will give 50 coupon payments per year, the market rate of interest is 50 by 500 is equal to 0.1. Now as you can see, if the current rate of interest increases, that is the current rate of interest, what happens to the bond price? Bond price decreases. If 0.1 become 0.2, 0.2, bond price become 200. So, and why? There is a reduction in the bond price if the current rate of interest increases. This is to ensure that the rate of return on bonds issued on different dates is same. In a competitive market, you cannot expect different rate of return on bonds issued on different dates. Stated differently, the rate of return on bonds issued on different dates must be same. So there will be price adjustments to ensure that return on bonds issued on different rates is identical. That is a point which we will discuss with a numerical example later. As an example, suppose that a console is issued at pound 100 at a coupon payment of 2.5%. Pound 100, coupon payment of in the 1930s. So, if the face value is pound 100 coupon payment is 2.5, rate of return is 2.5%, coupon payment is 2.5. Or we will say a console with a face value 100 and coupon rate 2.5 will give a return 2.5. Now suppose that a bond worth £100 issued at 10% in a different year. Today, it will give an annual income of £10. Coupon payment is £10, so the return is 10%. Here coupon payment is 2.5, so rate of return is 2.5. So, if the current year is say 2000, if a people hold bond issued in 1930s, giving a coupon payment of £2.5, then what is required is that price of this bond must reduce to 25. Then only the return 2.5 by 25 is equal to 2.5%. If and only if the price of this bond reduces to 25, the return on this bond becomes 10%. So even though when it was issued, the price was £100, now the price is only 25. This is to ensure that the return on bonds issued in different time periods will give the same rate of return. So we will say that there is an inverse relationship between the price of the bond and the rate of interest. When the rate of interest increases from 2.5% to 10%, the price of bond decreases from 100 to 25. Or stated differently, there is an inverse relationship between current rate of interest and the prices of previously issued bonds. If the current rate of interest is 10%, the price of previously issued bond decreases to 25. So there is an inverse relationship between current rate of interest and the prices of previously issued bonds. And as it is known to you, the current rate of interest is the yield on bonds, and it is the rate of interest which is used as a discount rate to make the present value of future income from the bond equal to market price. And in the case of a perpetuity, yield is equal to, naturally yield is equal to annual income divided by bond price. Annual income divided by bond price, 10% or 2.5% like that. So this is the inverse relationship between interest rate and bond price. We will discuss these examples once more when we consider the speculative demand for money. So remember this, in the Keynesian model, asset or wealth is kept only in the form of two assets, money and bond. Bond is a fixed income yielding asset. Its price is nothing but the present value of all the future claims. And to obtain the present value, we discount future payments with the current rate of interest. And if the current rate of interest increases, the price of bond decreases. This relationship is very important in the Keynesian theory of demand for money, which we will discuss once more later.